Morning, guys. Today, for the last 2 weeks of school, I thought we could do and go back into acid base and finish Unit 8, and then maybe jump into a little bit of Unit 9. But we really wouldn't finish it because we have 4 days this week, and I think it's 3 days next week with Memorial Day. So, in reality, there's just not a lot of time. So I don't want to jump back into the old units because we would finish Unit 8. But again, I'm not going to give you a test at this point in time. I wouldn't think that's logical with the AP test being last week. It is what it is. What I wanted to do then instead is in your email that I just sent out, I have an organic worksheet posted. So I figure we could do a little bit of organic chemistry, and if we finish organic chemistry before the end of the school year here, we'll jump into a little bit of nuclear chemistry. These are two topics that I usually go over after the AP test as well, just for fun. I really like organic chemistry. I'm sure I've said that a couple times this year. So I don't know. Figure we can do a little bit of it. Hang with me. If you're watching these videos every day with me and you're going through this stuff still and you're still sort of engaged with school, this is a topic that people think is really boring and not even remotely enjoyable initially. But once we kind of put all the pieces together, students tend to actually kind of enjoy this little organic intro. So, but you got to hang with me. You got to trust me on that one. All right. So what I'm going to do first is on your sheet you have just a blank spreadsheet, more or less. And again, this doesn't have to be on the actual worksheet. You can do this on notebook paper, but we'll take a smidge of notes today. And then I'll give you guys an assignment, and we'll start trying to practice some of these organic naming things. So with organic chemistry, the very first thing that they typically teach is naming. And let me give you a little background on what organic chemistry is. Organic chemistry is the chemistry of molecules that involve carbon, hydrogen, oxygen, and nitrogen. There's a couple others that sometimes get thrown in organic chemistry, but generally speaking, you're talking about 4 elements and only 4 elements. Which sounds like we're really limited in what we could, what there is, what there could be. But in reality, the vast, vast, vast majority of things that exist, especially naturally existing things, are made out of these 4 elements and nothing else. So it's a very, very wide range of chemistry. There's a ton we could talk about, but we'll start with naming. So let's just go through. The first type of functional group, and by the way, the functional groups are like little features, I guess you could say, or a way of identifying what type of organic molecule something is. So they have different names. So a functional group is just, hey, what feature is there on this molecule? So an alkane is a single bonded carbon chain. So it's chains of carbon, 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 carbon in a chain, all singly bonded. So for example, right, carbon bonded to a carbon, carbon bonded to a carbon, something like that. The other thing in organic chemistry is we completely ignore hydrogens. Okay, they're all there. There's hidden hydrogens all over the place, and I know we experienced that a little bit when we were looking at sigma and pi bonds in the other unit. But so in this molecule right here, there should be a hydrogen, 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 hydrogen. The idea there is that each carbon has 4 bonds. Okay. The next functional group, and again, if I'm going too fast, just pause it. Obviously, I'm going to keep plowing forward, but you can pause it and finish what you need to for notes before I switch the slide. Is an alkene. Alkene are doubly bonded carbon chains, and they would look like this. So it doesn't have to be fully doubly bonded, meaning we don't need like double bond, double bond, double bond all the way through. There just needs to be an individual double bond between 2 carbons anywhere in that carbon chain. So we have one right there, and again, there'd be hidden hydrogens. We'd need to have 1, 2, 3 hydrogens here, 1 hydrogen off of this one because this already has 3 bonds, so it only needs 1 more. And this carbon needs 2 more, so that would have 2 hydrogens coming off of it as well. Next, we have alkyne. An alkyne is a triple bonded carbon chain, so a carbon chain with 3 bonds somewhere in there. And again, much like I had said earlier, we're not going to have consecutive triple bonds, or it's not all triple bonds. It's just that there's 1 triple bond between carbons somewhere in that molecule, and this is called an alkyne. So, same thing, there's 1 hydrogen hidden here. This one has no hydrogens on it. It has 1, 2, 3, 4 bonds. So this carbon's actually full. It's good. And then this carbon, would need 3. All right, that's kind of boring. Single bond, double bond, triple bond, alkane, alkene, alkyne. Now we can go on to some other more unique molecules. An alcohol. An alcohol is when you have a hydroxide group attached to the organic molecule, so an OH group. And that's going to look like this. Here's my chain of carbons, 1, 2, 3, and somewhere on that chain, one of these carbons has an oxygen and a hydrogen attached to it, like this. So the hydrogen is always bonded to the oxygen, but it's like an OH group is attached somewhere to this carbon chain. And again, same thing as always, I'll stop saying it after this one, but 3 hydrogens still hidden here, 2 hydrogens hidden here, and 2 more hydrogens hidden on that last carbon. An ether. An ether is when you have an oxygen in the middle of your carbon chain. So, what we've normally had is carbon, 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 carbon. Now we have an oxygen stuck right in the middle of it. That's called an ether. All singly bonded. And I think if you were hanging out with me on one of those last 2 office hours before the AP test, I was talking about how carbon always wants 4 bonds, nitrogen always wants 3 bonds, and then oxygen always wants 2 bonds. So this oxygen has no hydrogens hidden on it whatsoever. It would have 2 lone pairs, but it has 2 bonds, so it's actually right where it wants to be. An aldehyde. An aldehyde is when you have a doubly bonded oxygen at the end of your carbon chain. So here's my chain of 3 carbons, and I have a doubly bonded oxygen right at the end. Next, a ketone. A ketone is when you have a double bonded oxygen in the middle of the carbon chain, and that looks like this. Okay, so instead of having that double bonded oxygen on the end, we have it in the middle. And by the way, I know we're taking notes. I know this is pretty miserable if you're actually following along with me, but we are going to use these. Okay, I am going to give you what we'll call like a quiz, but it is full open note, obviously full open internet. But I'll give you examples that you probably can't find on the internet, so I think we'll be okay. Anyway, so yeah, sorry. Ketone is a double bonded oxygen in the middle of your chain, your carbon chain. Carboxylic acid. This is when you have a hydroxide, OH, and a double bonded oxygen at the end. So this is actually, these 2 things come in tandem. They have to come together. You have a hydroxide group and a double bonded oxygen at the end of a chain. So this is going to look like this. I only have a chain of 2 carbons in this example, but this at the end, this last carbon here has a double bonded oxygen as well as an OH group coming off of it. So these 2 things, the double bonded oxygen and the OH group together at the end of a carbon chain, is what we call a carboxylic acid. Okay, so this is actually acetic acid, which we've talked about a whole bunch. But yeah, again, you wouldn't know the structure of it without looking at organic chemistry. This is acetic acid. Ester, not an old lady in a nursing home. This is ester, the organic molecule. So an ester is when you have an oxygen next to a double bonded oxygen in the chain. So it looks like this. In the middle of your chain, so here I have 2 carbons and another carbon on this side, I kind of have that double oxygen situation in the middle instead of at the end. So the carboxylic acid, I had 2 oxygens on the same carbon, but it was at the end of the molecule. In the ester, I have 2 oxygens bonded to the same carbon, but it's in the middle of the chain. So there's a double bonded one, and then this one goes in the middle of the chain like that, and that's called an ester. Amine. Amine is when you have a nitrogen. So carbon, carbon, nitrogen. I wrote this as NH2, but in reality I could have written bond with an H over there, and then bond with an H over here. Doesn't really matter how you draw it, but a nitrogen in the chain is called an amine. Amide, or an amide, depends upon how you hear it, but well, we'll go amide, is a nitrogen group next to the double bonded oxygen. Something that looks like this. So I won't use amines and amides too often, but every now and then I might sprinkle them in. Yeah, and then here's your carbon chain, and instead of having like an OH group, right, because we had a double bonded O with an OH group, that's called a carboxylic acid. This is just going to be a double bonded O at the end with a nitrogen group as well. Cyclic molecules. Cyclic molecules sound exactly like what you think they would be. It forms a ring. All carbons, and it forms a ring, closing more or less your carbon chain. There's certain sizes of rings that can exist and certain sizes of rings that don't exist. Once you get to too low of a carbon count, the angles of those bonds get really tight and they don't actually stabilize, they'll break. Epoxy glue, for example, is an example of a cyclic carbon molecule that when the glue sets, that ring is broken and it's more stable and it solidifies very, very strong. So just a side note, I don't know if you actually care, but you know, whatever. And that's it. So that's it for my functional groups. I think that's all I want to do today. I want to keep it kind of simple. I want to keep it kind of straightforward. Um, yeah, so I hope this was a quick 10-minute little note video. Again, please take those notes if you're following along, and we'll pick this back up here tomorrow. And if you guys have any questions, please let me know. And yeah, we'll see you then.